So Troy asked me to kind of talk a little bit about the future of cloud communications. And that's kind of an interesting topic. So it covers a lot of potential different things. Over the last 2 days, you've heard about the application of communications to lots of different business problems. Business transformations, dealing with business resilience activities, the Internet of Things, proactive customer communications, tying into lots of different areas within IT, whether it's major incident management, tying into your service management platforms, IT operations. There's really no shortage of applications to communication technology in its most general sense. So what I really want to cover today was not really focused on any particular application, but on the communication marketplace in general. And I think this will be kind of an interesting topic for you guys to go through, but it helps to have some context. When we're talking about communication, we could really talk about anything. So I thought it'd be helpful to set the stage with something that we can all probably relate to. So what I thought I'd do is walk you through a little bit of an example of the different things that might be involved in having a very simple communication activity take place. An activity that we probably do, probably most of us go through every day, a virtual meeting with a small group of people that you want to have with your distributed team. Some people in person, some people connected remotely through your collaboration technology of choice. And I'll use xMatters as an example for this particular occasion. So I'm based out of our corporate headquarters in the San Francisco Bay Area, in San Ramon, if you're familiar with the area itself. There, our telecommunications is provided by a company you may recognize, which is Time Warner Cable. They're our provider. We have teams that are, of course, all over the world. That includes people who are local. So we actually have an intern who works for us on the East Coast. Their internet connectivity is provided by Cox Communications. We have a group that's based out of the UK who works very closely with Rob. That's our UK team that's based out of London. Their network connections are powered by Vodafone. We also have a group that's based out of the UK, whose eventual network technology is provided by NBN. So kind of 4 different disparate companies, networking technologies, really coming together to communicate effectively to drive that basic conversation. But it's really more than that. Now, when I'm in a meeting myself, we generally have lots of different rules and topics we want to follow. So for this topic, there's a topic that we really want to go through and talk about related to just recent market swings. We want to talk about our company 401k and other retirement plans, which are powered by Principal Financial Group. So we need to use all those networking technologies to really hit that particular company's website and review some of the great performing funds that are part of our plan from Baird. Now, if I'm at any given meeting, or if I'm on stage, or in fact, if I'm doing anything at all, I generally get kind of hungry no matter what I'm doing. So I like to have snacks. My snack of choice, so I'm just kind of walking around. It's a box of cereal. So while I'm up here, I'm going to have some Frosted Flakes, which are my cereal of choice. While I'm doing that, of course, we have to buy that from somewhere. So I choose to buy my groceries where I can at our customer. So from a Kroger location, which I paid for with my US Bank credit card. And our teams across the world, of course, also were hungry. So in preparation, they wanted their own Kellogg snacks as well. Our intern is a student at Vanderbilt University who came into place to actually pick up some Pop-Tarts, which he picked up from a store that was powered by SunTrust, while our UK team picked up their Kellogg snacks at a Tesco location, which happened to be testing out some food safety technology run by Ecolab. As part of this conversation, since we were talking about Kellogg's, we of course had to take all the money from our purchases, eventually want its way into the Kellogg's story, or into the Kellogg's financial coffers, which are powered by TCF Bank. And since we heard about Kellogg's widely globally deployed infrastructure, they engage the services of Axiom IT to actually support those technologies. And as part of that recommendation, to actually fund the shipping and activity of those systems, the shipping is actually, of course, energy powered. The shipping tankers run on oil, which is delivered by Marathon Oil. And that was a recommendation that they got from one of the other companies, Capital Group, which of course was a recommendation to use reinsurance from the Reinsurance Group of America to drive that. Our Australian team, unfortunately, was unable to complete that conversation because we actually went through a scenario where they were attacked by drop bears and had to be rescued by someone who got a call from the wire system. That's kind of a random selection of companies. In case you haven't put that together already, these are all of our speakers from the event today. And you can take really any group of companies and you can probably come up with the business process that connects them all together. Something that's very, very simple on the surface. All I want to do is get together with our local group of employees from our company, talk about a very simple thing, actually could engage a lot of different companies in lots of different ways. Every one of these different companies you're utilizing, for those very simple transactions or interactions to take place from a business process standpoint, requires a lot of things to work perfectly. So as an example, I couldn't have a Skype conversation with anyone if there's a problem in the Time Warner communication network. Within that environment, there are literally tens of thousands of networking nodes that have to be pulled together. Billing services, provisioning services, network services, peering relationships with other providers, all those things have to be working perfectly for that to happen. When anything goes wrong within any of those business services, people need to work together to solve them. In fact, if you look across all these interconnects, and it's actually very simple, and actually totally made up example, by the way, so if I've made some assumptions about business relationships that don't actually exist, that's for the purpose of illustration only. Every one of those conversations actually requires lots of pieces of technology to work together. In fact, it's kind of a miracle. Every time we do any of these sorts of things, it's amazing that it actually ever works. There's so many moving parts and so many different companies that have to work together to actually pull it off. In fact, if you look across any of these given processes, these are all very, very complicated and intricate components, and they all involve lots of people. And all of these components have to work together for this stuff to actually happen. And what it really creates is a large global mesh of interconnected companies, business process, and technologies that are all connected together in wildly complex ways. And you can really slice up the world in any sort of mechanism you'd like, and you'll find that complexity. The business relationships I showed earlier was one example. You can look at simple interconnect. If you've ever looked for Google a map of the internet, you'll find pictures like this, which really, I have no idea what the hell that is or what you could do with it, but actually represents a link of the very first tier of complex internet connections that it takes to really drive that sort of view together. But it's not just networking. You can actually look at the world in lots of different slices as well. You can look at it from a transportation and logistics perspective and see that interconnection complexity. If you're looking across shipping lanes and road networks that move most of the materials we take for granted, that in itself is very complicated. Every one of those touch points is driven by lots of different communications. Is the ship on time? Are there communications happening in place? All the various supply chains run on these large global networks. And they really come together to form this amazing picture of the world working together to deliver any of the services that we take for granted. And the really interesting thing about it is every one of these processes, no matter how you look at it, they all sit in between people. So there are people at the beginning of it, something like me saying I'd like to have a meeting with someone, and there are people that are at the end point of it, who are actually receiving information, requesting goods and services, and every time any of those interconnections break, people have to come into place. So as much as we have all the automation in the world we have, people are really a key part of these given solutions. Now, you've probably heard in lots of different presentations, through lots of different analyst meetings or leadership things, lots of different stuff about technology megatrends. So I'll spare actually putting the acronyms and the things back up on the screen. We've probably heard the acronym SMAC at some point. That's not referring to the delicious illegal drugs that you get that go by that name, but actually referring to the four generally recognized megatrends that exist in the technology world today: social, mobile, analytics, and cloud. Those are the major things that are actually driving transformation in our industry, and communication is no exception. When you look across that large array of interconnects and complexity in the world today, all those are being driven by the fact that we have more and more information about what's happening in the world. The physical infrastructure, all interconnected, producing lots and lots of information. What used to be a very basic set of simple system alerts, technology alerts, servers, applications, those generating alerts, now it's everything. Anything actually, whether you're walking into an environment with a phone and there's local beacons alerting a retailer about your presence in that store, or you're dealing with a refrigeration system telling you that your ice cream is getting to the point where it's potentially going to melt, all that sort of stuff all generates lots and lots of data and centralizes through analysis and back out through an even wider funnel to a larger and larger audience. So it used to be things like you'd have to wait at home for a technician to come and fix your cable or wait for a package to be delivered. That data being tracked across all those systems makes it possible for you to get an alert that in the next 15 minutes a UPS man is going to show up with your new iPhone 6S. Those sorts of technologies are only made possible by those sorts of elements. And in the middle of all these processes sit people. So whether you're an initiator of a system, fixing a system, or a requester of a system, there are people in the middle of these systems. And we are not yet, and I use yet, instrumented to automatically receive this information in our brains. We actually have to be communicated to using things that work with our feeble minds, things that we can touch and feel: text messages, emails, phone calls, telephones, mobile application pushes. The communications wind up being at the hub of these lots of different conditions. In fact, the scale is increasing at a faster and faster pace. And in fact, most organizations have zero ability to scale at this on their own, which is where the cloud technologies come into play, where we get more and more specialization in different domains to scale these different things out. So what it used to be was in order for your business to be agile, you had to be able to react to build out compute resources on your own. Today, if your organization is not looking at public clouds or building out very complex private clouds if you need to deal with compute requirements, you're simply not going to be able to adapt to the wave of the future. And that same disruption is happening in communications. In fact, if you look at a general trend, you've probably heard the phrase, I think it was Mark Andreessen who used it first, describing software eating the world. That's really true of any business you look at, any activity we take out in place, you can probably look at it and look for an area where software is basically transforming that business. We heard about it from, in the context of the Weather Channel, a weather network turning into a data business. It's kind of a big transformation. You're probably familiar with all the common stories you hear about. Transportation networks being turned upside down by Uber, as an example. That's on a scenario where software is basically transforming a taxi industry. It's transforming the way we consume transportation in the most general sense. It impacts the insurance industries. It impacts the automotive industries. All those sorts of things come into play. Then an accelerating pace in any given marketplace that we're also seeing is a further consumption of complex software problems being broken down into very small APIs. So it used to be very complicated technology problems that were not only the domain of incumbents and large organizations, are also becoming the space of very small companies that can access that complexity at will. An example of that is machine learning. If you were to go back and look at complex machine learning activities, it was a very, very large R&D and technology companies that could pull it off. Then it started to go downstream into software companies who could build specialized capabilities to turn those on their heads. If you'd said that the first developer of artificial narrow intelligence, or narrow artificial intelligence, sorry, I got my acronyms upside down there, those were going to be newer companies like Google as an example, that would have sounded crazy 10 years ago. Today we take for granted that I can go through and say, okay, Google, and ask information in multiple languages and receive results instantly. We take that for granted. That same technology is becoming available through APIs to very young companies. So machine learning that used to be a massive R&D project is something that you can access today as a simple API. And we're seeing the exact same thing happen in the world of communications. What used to be a very, very hard problem of guaranteeing the delivery of a text message or any given message to a person anywhere in the world is no longer a challenge that's something that's limited only to very complicated software. It's available much more accessibly through APIs. But I think it's important to kind of have a little bit more context to drill into this in more detail. So I'll give you an example that we've been talking about in the general sense for the last couple of days. So think about an automated system like Splunk as an example for this particular scenario, detecting a problem in a system and going out and delivering a message to a person who has the right context to be able to respond to it. Lots of things happen in that sort of scenario. You kind of have to ask yourself saying, well, how did that happen? So as an example, how do we decide what the message was going to say? Who is actually going to get that message? What was the message actually going to look like? Who is going to see it? What channel was it going to be received on? How do we make sure it got where it needed to? And how did it actually make sure it got to the right place in the world across all the different devices that existed there? Now, at the surface, you'd say, well, if you're using something like xMatters, you can kind of at a high level say, well, that's kind of what we have xMatters for. But there's actually a little bit more depth to it than just as simple as that. In fact, the best way to examine this problem or any of these sorts of these transformations is look at them in terms of layers. To start at the very top, if you were to go through and start at the mobile device level that message is on, that message appeared to you because of a mobile app. That ability for someone to publish a mobile app and have a dedicated communication channel for a business process would have seemed crazy 10 years ago. 5 years ago, it probably would have been seen like, oh, it's kind of an interesting sort of nascent market to look like. The ability to have a mobile operating system that could handle the complexity of security and delivering the message, guaranteeing the responses, tracking all that stuff, would have seemed crazy. Companies have actually fallen apart and completely died in those things. That's why we have a fossilized layers. You're going to see operating systems like the BlackBerry operating system basically be fossils in this different marketplace. And you can keep going downstream. Go down to wireless providers, go down to the wireless networks, go down to wireline networks connecting those different service providers, get right down to the fiber interconnects that traverse the world to make all these communications happen. At every single one of these layers, there exists the ability to transform these systems and make them accessible through software and through API. The idea here is that today's hard problems in communications are tomorrow's simple solutions they can build a company around. In fact, it should be possible, and there is no technical reason today why it's not, Or I could decide tomorrow as an individual to start a cell phone company and have a global cell phone roaming company tomorrow. All I need to do is have the APIs available to build those things together. And that's the level of transformation we're seeing in the communication world in general, is the ability to make the things that were very, very hard, make them very easy in the future. And that's a general directional trend that we take. There's a mechanism to actually evaluate your application to this. So from a practical standpoint, here's how we kind of look at the future of cloud communications and generally the future of technology in the world as we see it today. There's really two themes of thought. This is a quick show of hands. How many of you are familiar with the pets versus cattle analogy for technology? Got to block a light so I can see a show of hands. Not a whole lot of folks. It's actually, I see one. All right, so I see two hands actually. So there's a gentleman by the name of Randy Bias. He works for he's the first person I heard use this particular analogy. The idea here was that to think of any given technology in one of two criteria. You can either think of it as a pet, and I'll give you the example in compute, because that's probably the one most people can relate to very easily. Think of technology either as a pet or cattle. So let's look at it in the context of compute. I want to have an amazing, huge server, in fact, a pair of servers, so they're HA, they back each other up, they're super high performance, they're the best blade chassis money can buy. When people come over to visit my company, I'm going to walk them over there and say, check out this machine. Isn't she beautiful? It's amazing. Why don't we take a picture together? That's a pet. You care about that resource. It's scarce, it's limited, it's part of your family, you care about it, you take pictures of it, you have care and feeding for it, you make sure it's healthy and looked after. That's the compute example of having a pet. The cattle example of pet is you actually have no relationship with the compute layer at all. If you need more compute, you get more compute. It provides a service. It gets you milk, it gets you cheese, it gets you yogurt, it gets you steak when you're hungry, and it basically feeds you. It provides a very, very simple service. That's the cattle model. In the pet model, it's very expensive to scale up because it's a scarce resource. You have to look after it. You can't just adopt as many pets as you want. That's crazy. How many people can we have? Now we have, I think, Zoe in the crowd. She's got a lot of cats, so she's a little bit of an exception. She has a lot of pets. But for most of us, there's only so many pets you can actually realistically absorb. But cattle is different. You think of them as by efficiency. I need more milk tomorrow. I plan for it. I get more cattle. I get it out there, and I'm ready to go. And that's actually how you should evaluate every piece of technology that you own. If today you look at communications from your key systems out to different people as being something that you hold near and dear to your heart, that it is this amazing thing that we're going to look after, and we're going to basically go out and buy a bunch of complicated communications equipment. We're going to fire up a call center to look after these different conditions. You basically have yourself a pet. And that's not what you want. Pets are actually very expensive and come in the way of scaling out your businesses. Unless you're in that particular pet business, you really don't need to have anything in that. And that's really a model you should be looking at. So as an example, if you look at the process of your operations center and you look at the team that's in there and you think that it is amazing that they have spreadsheets and SharePoints and whiteboards and a unique process to actually go out and evaluate who to contact when something goes bump in the night, and that's something that you hold as key value to your organization, you have yourself a pet. You don't have cattle. If you look at it as it's simply another system. If you add another team, add another application, I simply slot it into an automation system and it happens, you've got a cattle mentality. And that's actually the approach you want to have for these sorts of technologies. Look at them as being replaceable, easy to scale, and not really something that you attach a lot of inherent and kind of attachment and high value to. It's something you should be able to go out and scale out very, very quickly. And it's a model that we think is something that's going to happen more and more in the technology world. So in a similar sense, in the example we heard from the Kroger team, if you think that it's very, very critical to you guys to go outside and have folks run through aisles checking temperature on refrigeration units, and that's a high value task, you have a pet mentality and not a cattle mentality, when really that should be looking at something that you can and should be looking to automate as quickly as possible. It's an important thing to actually note out in here is as you go through those layers, you should be looking at every one of those layers and the purpose it serves for you guys in a particular business process and evaluate what can you do to automate. When you're looking for the ability to go out there and identify what the future of anything looks like, that's kind of the model you should be looking at. So when people ask me saying, what really is the future of cloud communications? I apply all those things in general. I look at it as saying, I don't want to be so attached to this thing that it actually prevents my ability of my business to be agile, to operate at high velocity, and to be able to adapt to change quickly. So in order to do that, I can't have this stuff be in hardware, be it hard-coded, live in locked-in systems. I need it to be free. I need it to be software-defined, so I can actually go through and adjust my business process I need to. Whether it's adding new response choices, modifying content, adjusting the channels to use, all those sorts of things have to be free. I have to be able to go through and adapt them as I need to very quickly at low cost and scale them out. And that's the way we actually look at it. So all the various criteria that you see on here, having things be elastic, having them be API accessible and not be driven through locked-in systems, all those things have to exist all together in one place. It's also important, just by virtue of all of our businesses as they operate today, a natural global scope to it also has to exist. All those components together have to work at a global scale, or you're simply not going to be able to, you don't have the right solution in mind. The other thing that you're going to see is, as we see a further fragmentation in the communication marketplace from a channel perspective, the ability to actually unify across channels is going to become very, very important. So when I look at my cell phone, and I put it away so I wouldn't get signal noise, but if I look at the home screen of my cell phone, I have probably a dozen different communication channels available to me right there. Whether it's telephony, text messaging, I can get emails, I can get mobile application pushes, but that's not one app. Every channel carries its own unique communications, whether it's Facebook, LinkedIn, Twitter, Viber, Line, Skype, WhatsApp. Every one of those is unique communication channels that can keep layering on additional ones. So unification across communication channels becomes very, very important. And the other piece that we talked about in context of that Splunk message is intelligence on top of who's going to get the message. So as you go through and actually start to make more and more software-based decisions at the raw communication layers, like simply saying make a phone call as a software call versus having it run on your own infrastructure or your own hardware, you also have to start to add in who is going to get the message, what is the message going to contain. Those are the other things that get subsumed by your communication layers. And that's really how you evaluate the communication technology that exists today.